Brain-computer interface, or BCI, is an emerging technology with widespread influence on clinical as well as entertainment-based applications. Electroencephalogram, or EEG, which is a simple and non-invasive method, is popularly used for brain signal acquisition. There are various mobile, lightweight and less expensive EEG devices available in market today, which allow development of commercial BCI applications. A recently introduced wireless neuro headset, Emotive Epoch, allows good quality measurement of EEG. Numerous BCI-based games have been developed by scientists and researchers using Emotive. This type of brain training games promise a gradual enhancement of the user's attention and cognitive skills. In this video, a brain control game is showcased that uses signals recorded by Emotive to enhance attention and cognitive skills. This headset has a provision of 14 electrodes. Before mounting the headset on the user, felt pads in the sensors have to be properly hydrated with saline solution. This is to enhance the conductivity between sensors and scalp. When the headset is switched on, it communicates with the computer through a USB dongle. This shows the Emotive Epoch test bench, which displays the recorded raw EEG signal. On the left, you can see the scalp-mounted sensor map. The good contact quality between scalp and the electrode is indicated by the color green. Here, we can see the list of 14 EEG channels available in Emotive Epoch. The interface of Brain Matrix game is shown here. To play the game, the player has to regulate his attention or concentration. The better he concentrates, the higher score he gets in the game. The main part of this interface is a 3x3 matrix. At first, a set of numbers are displayed in the matrix. The player has to memorize these numbers and their locations so that he'll be able to refill them correctly using his brain signals after a few seconds. The number of elements displayed in the matrix varies depending on the difficulty level of the game. For level 1 game, 3 elements will be displayed. For level 2, 4 elements, and for level 3 game, there will be 5 elements. 3 progress bars can be seen in the interface. The main bar on the top of the matrix presents a real-time attention score of the player. This value is computed from the entropy values of the recorded signal. Higher the level of attention, higher is the attention score. Real-time game scores, that is, the number of correctly filled elements and the completely filled matrices achieved by the player, is indicated in the other 2 progress bars. Now, we can watch a user playing the Brain Matrix game. As the laptop starts communicating with Emotive, the varying attention level of the user can be observed. As the user starts concentrating, his attention level increases, and this is displayed in the progress bar. Now, he starts playing a level 3 matrix game. 5 numbers are displayed in the 3x3 matrix, and then the screen becomes blank. The user memorizes these numbers and their respective locations in the matrix. After 2 seconds, one of the matrix locations will be highlighted. Choices for the answer appears on either side of the matrix. The user can continue the game if he concentrates well and his attention score rises above a predefined threshold value. If the player maintains his focus for the next 3 to 4 seconds, 2 arrows will appear next to the answer test boxes. Now, the user chooses the answer using keyboard. He needs to press keyboard button A for selecting number in the left test box and L for selecting number in right test box. If his attention is less than the threshold value, the arrows will not appear and the player cannot input his answer. In that case, he will have to wait for the next element. If the player has selected the correct answer, a smiley appears in the test box and it moves to the respective test box in the matrix. The speed of the smiley is proportional to the attention score. Now the next element appears and the player continues to play in the same manner. In order to complete one game, the player has to fill 6 matrices. When the game ends, the player is notified with his game performance measures such as scores, average attention score, average time taken for answer selection, etc. The signals recorded from various players have been analyzed further, and the benefits of this game have been identified. The performance of the player based on his game scores is found to increase day by day. The ability of a person to focus and control his respective brain signal is found to improve. The graph shows the game scores obtained for a group of 8 subjects who played the game continuously for a week. As observed, there is a significant improvement in the game score on the last day compared to the first day. The attention score values directly computed from EEG signals for the same group of subjects is displayed in this graph. It is interesting to note that for all the players, the attention score or the ability to concentrate has been enhanced significantly. Other research studies also have shown the promising capabilities of BCI-based neurofeedback games to enhance brain power. The future of BCI research lies in the development of more sophisticated technologies in both hardware and software. Such inventions and developments will surely help to explore the full potential of BCI. By this, we hope to achieve the end goal of BCI, that is, the absolute transformation of thoughts into actions.